All right, let's dive into one of the most critical topics in tech right now. The brand new, often invisible dangers that are facing the AI tools we're all starting to use every single day.
I mean, it's impossible to ignore, right? Generative AI is changing everything. How we code, how we write, how we create. It's a full-blown revolution, and it's happening at a dizzying speed.
I mean, it's happened way faster than anyone thought, right? LLMs aren't just a cool science project anymore. They're getting woven into our apps, our jobs, our daily lives. They are fundamentally changing the game.
And the stuff they can do, it's just staggering. These aren't just simple tools, they're more like collaborators. They can write code, they can analyze complex legal documents, they can even whip up a poem if you ask them to. But all that incredible power, it comes with a shadow side. The very thing that makes them so amazing, their ability to understand and speak our language, also opens up these weird, almost psychological weaknesses. We're not talking about your typical software bugs here. This is a whole new class of security risk.
But, and this is the big question, as we're all rushing to build on top of this amazing new tech, are we building on a solid foundation? Because this new AI frontier, it comes with a whole new battlefield of threats, dangers that our traditional cybersecurity playbook just wasn't built for.
So, to help us navigate this new landscape safely, the security community created a super important guide, the OWASP Top 10 for Large Language Models. You can think of this as the essential security checklist for anyone building or deploying AI today.
We're going to break this down into a few key areas. First up, the input threats. This is all about how bad guys can sneak malicious data and commands into the system to begin with.
And kicking things off at number 1 is the big one, LLM-01, prompt injection. Seriously, if you only learn about one threat today, make it this one. It is the absolute foundation for almost every other security issue we're about to talk about.
You know, security pros have a really powerful way of describing this. They call it the SQL injection of the LLM era. And that's a perfect analogy. It's an attack where you basically trick the AI into throwing its original rules out the window and instead following your malicious instructions.
So, what's the worst that can happen when a prompt injection attack works? Well, that leads us straight to number 2, LLM-02, sensitive information disclosure. This is the direct consequence. This is what's at stake when the model gets tricked into leaking information it should never, ever share.
And we're not talking about small leaks here. We're talking about the crown jewels, API keys, passwords, even the model's own secret instructions. Private user conversations, confidential documents, all of it can be exposed. And the core reason this is possible? The LLM itself has no idea what's supposed to be public and what's private. To it, it's all just data.
This brings us to a really sneaky one, LLM-03, supply chain vulnerabilities. This is a crucial reminder that attacks don't always come through the front door. Sometimes they come from the very data and components your AI is built with.
Think about it. A vulnerability can be hiding anywhere in that chain. You could have malicious instructions hidden inside a PDF that you ask the LLM to summarize. You could download a compromised open-source model from a place like Hugging Face. Or the very data used to train the model in the first place could have been poisoned.
Okay, so if the inputs and the entire supply chain are this vulnerable, it begs a pretty obvious next question, right? What about the model's own internal knowledge? And more importantly, what about its ability to actually do things?
And that brings us to our second big category, the processing and action threats. This is all about how the model's internal logic can get corrupted and how its outputs and its ability to take action in the real world can be turned into weapons. First in this group is LLM-04, data and model poisoning. Now, this is different from a one-off prompt injection. With poisoning, an attacker is trying to corrupt the model's training data itself to permanently teach it biased, malicious, or just dangerously wrong information that it will then serve up to other unsuspecting users. Next up is LLM-05, improper output handling. This is a classic security mistake, but with a terrifying new AI twist. It's the danger of just blindly trusting whatever the LLM gives you, treating its output as if it's always safe and correct.
Because an LLM can totally be tricked into generating malicious code, harmful database queries, or nasty scripts, and if your application just takes that output and runs it directly, well, you've just used your helpful AI assistant to punch a massive security hole in your own system, opening the door to old-school attacks like cross-site scripting or SQL injection.
Building on that, we have LLM-06, excessive agency. And this is where the risks start to feel a little like science fiction, but they are 100% real. Agency just means the LLM can take real-world actions, things like calling an API, sending an email, or changing a file.
An LLM with too much power and not enough oversight can be manipulated into abusing its tools. An attacker could trick it into deleting critical files, stealing company data, or even making unauthorized purchases. The analogy here is perfect. It's like giving full system access to an intern who is brilliant, but also believes everything they read. It's a recipe for disaster.
Okay, finally, let's look at the last 4 threats together. These are what you might call systemic vulnerabilities. They're weaknesses in the overall design and operation of the entire AI system.
Okay, let's talk about number 7, system prompt leakage. You know how every big LLM has its own personality, its own set of rules? Well, that's defined by a hidden set of instructions called a system prompt. It's the secret sauce. And this attack is all about tricking the model into telling you exactly what's in it. It's exactly like a magician revealing the secret to their best trick. Once that system prompt is out in the open, attackers can see everything, the exact rules, the guardrails, all your internal business logic. And once they have the playbook, it becomes so much easier for them to find the loopholes and figure out exactly how to bypass all your safety measures.
Coming in at number 8, we have vector and embedding weaknesses. Now this one gets a little more into the architecture of modern AI apps. See, the attack surface isn't just the LLM itself, it's also the special databases that feed it information, what we call vector databases. These are crucial for things like RAG, or Retrieval Augmented Generation, which is just a fancy way of saying the LLM can look up information before it answers.
The easiest way to think about it is like this. A vector database is basically a private Google for your company's internal documents. But here's the problem. They often don't have the same heavy-duty security filters you'd expect from Google. So an attacker could poison the data in there to set up a delayed prompt injection, or they could craft these really clever search queries to trick the system into pulling up sensitive files that it had no business accessing.
Next up, at number 9, is a threat that literally weaponizes the core purpose of an LLM. We're talking about misinformation. This is all about the model's incredible ability to generate things that sound super convincing, but are completely false or even dangerous.
And what's really crucial to understand here is that this is a content layer exploit. The attacker isn't trying to hack the system itself. Nope, they're just manipulating its behavior to make it produce something that looks trustworthy but is actually deeply flawed. We're talking about things like getting it to suggest insecure code snippets or give out genuinely harmful advice to an unsuspecting user.
And that brings us to our final risk, number 10, unbounded consumption. This one's a little different from the others. It doesn't go after your data. It goes after your wallet. It's basically a denial-of-service attack that's designed to make your costs spiral out of control.
Just imagine giving someone a blank check for a machine that charges you by the word, and it never, ever gets tired. That's what this is like. An attacker can cook up a prompt that sends the model into a crazy recursive loop, or just makes it generate mountains of text. Before you know it, you've got a massive, unexpected bill, and your legitimate users might be locked out of the service entirely.
After that whirlwind tour of the top 10, what's the one thing you really need to remember? Well, it all comes down to the core takeaway. You have to adopt the right defensive mindset.
If you take just one thing away from this whole explainer, let it be this quote right here. Think of an LLM as a very smart intern who follows any instruction in the document. This isn't just a bug you can patch. It is a fundamental behavioral weakness of the technology itself. When you really look at it, all 10 of these threats boil down to 2 fundamental flaws. For all the input and data attacks, the flaw is that the LLM trusts all text equally. It has no way to tell the difference between a developer's trusted instructions and an attacker's malicious data. And for the action and agency attacks, the flaw is that the LLM has absolutely zero security common sense. It will just do what it's told, even if that means destroying the very system it's running on.
Which leaves us all with one final, pretty urgent question. As AI becomes more and more a part of the backbone of our world, of our economy, and our infrastructure, are we actually prepared to secure it?